Here you can see that I've installed the entire setup. Right now, both the indoor and outdoor units are connected to each other. The fault in this is that its outdoor fan is not working properly, so I'm going to fix it today. Now, the possible fault could be that the fan itself is damaged. Apart from that, there might be an issue in the outdoor circuit that's not turning it on, which is causing the problem. So let's see that the main issue is. So first, I'll connect the power. I've turned on the circuit. The outdoor circuit is now on, and its LEDs 1, 2, and 3 turned on and then went off. Apart from that, there's one more LED that is on here, so now we'll have to wait for a while. After waiting, we'll find out what the actual fault is. The indoor fan motor has started running, and now we'll wait for the outdoor fan and compressor to turn on. Once they start, we'll be able to identify what the issue is. So as you can see, it has shown an error. This is error 39, which means it's an indoor fan motor error. It means that this motor is not compatible with this system. So I'll try the communication again. Now I'm turning the system on again because I've replaced its indoor fan motor. I've connected the power again, and as soon as I did, the system turned on. Since there was an error earlier, I'll turn it on once more using the remote, and now it's on. The outdoor unit has turned on properly. There's no issue in it. The compressor has also started up. It's running perfectly in its place now. Now let's move to the fan. The fan hasn't started, even though its wires are properly installed. As you can see, it's not rotating at all. There's no vibration in the fan whatsoever. Now our system has shut down again because error 39 is showing on the display. Now let's see. Error 39 is related to the indoor fan motor, so it doesn't concern us much. Our main concern is with the outdoor unit, so let's check what fault is there. Now we'll first check this fan to see whether it's working properly or faulty, because if it's damaged, that could also cause the issue. Always start by focusing on the smaller faults first so we don't get stuck chasing the wrong problem. Because sometimes the issue is something minor, but we start looking for major faults, and that's a wrong practice. Now we'll check this fan to see whether the wires of the internal coils are properly connected to each other, and if the readings we get are not faulty. If the readings turn out to be bad, it means the fan motor itself might be damaged. If we look at the fan motor's diagram, it makes our work much easier. So when we look at the diagram, we can see that the red wire is the common point, the black wire is our electric or neutral line, and the capacitor is connected between the black and blue wires. Now I'll check whether their resistance values are proper or not. As we know, the red wire is our common point, and the other two wires are for the run and start winding coils. So let's check their values now. As you can see, we're getting a resistance value of 174.6 ohms, which means this is the point where we're getting the run winding value. Next, we'll check between the red and blue wires. Here, we should also get a low value. And as you can see, it is low, which means this is start winding coil, and it's working fine. Now let's check between the black and blue wires. Their value should be high. After checking, we're getting a resistance of 335.4 ohms, which means this point has the highest resistance. That indicates this reading includes the total resistance of the running coil, starting coil. But after this, there's one more thing we need to check. The body test. When we test the motor body with any one of the wires, we'll know for sure. During this test, no resistance value should appear. That means the body is properly insulated and there's no leakage or short. Look, when we touch it to the body, there shouldn't be any resistance value or reading showing on the meter. That indicates that the motor isn't shorted to ground, meaning there's no leakage inside it. So now we've confirmed that the fan motor is completely fine. There's no issue present in it at all. Now we'll test its circuit to find out why it isn't able to properly turn the fan on. To trace the fault, we'll start with these points on the PCB because they're clearly labeled AC fan, line, neutral, and capacitor. So it's straightforward. Now we'll check at these points whether the required voltages are present or not. We'll set the multimeter to AC voltage mode, then I'll supply power to the system. Now the PCB has turned on and the outdoor unit is also running. We'll wait a little while. The indoor fan motor has started, so now I'll check because sometimes certain units turn the fan on a bit later. As you can see, we're getting 234 volts AC here, which means the voltage is present at this point. We'll wait a little longer for the compressor to turn on. Once it does, we'll know for sure. the same voltage remains stable, and normally, this is more than enough for the fan to operate properly. It hasn't started the compressor yet. We'll have to wait a little longer. The voltage is present here though. As you can hear, the compressor has started. We've had 234 volts coming in for quite some time, so that should be enough. If the voltage is present here, then the outdoor fan motor should have started by now. Now let's test one more thing. Look here. This relay is installed, and from the relay, the output goes toward the line. So you can see that the current flows from this point to that point through the relay. So now let's check these points to see whether electricity is coming through or not. We'll check it in DC voltage mode. So let's test it now. As you can see, there are 12 volts present here. That means the relay is receiving power and switching on. However, this also indicates that the relay itself is internally faulty, since even though it's turning on, it's not passing the output properly. So I'll replace this relay and see whether, after changing it, the fan turns on or not. I'll also check the continuity at this point. There's no continuity present here, which makes me suspect a fault in this relay. So let's change this relay. Now I'll remove this relay because it's not turning on. That means it's turning on, but not working properly, so I'll take it out. I've removed the relay. Now let me show you what the fault is inside it. When tested with the meter, it seemed like voltage was present, but the outdoor fan was not running. That's why it's very important to test this relay to confirm whether our system is actually working or not. I have a 9-volt battery, so we'll use it to test this relay. First, I'll connect all the points on the relay. I've attached both wires here. Now, normally it should be disconnected because when it's off, it remains open, so I'll check it. We'll set the multimeter to continuity mode. Our meter is working perfectly, and there was no resistance value shown here, so as you can see, it's completely fine. Now I'll test it with the battery, and as you can see, this relay is faulty. Let me play the sound for you so you can hear it. The relay is energizing, but its contact points aren't working, so I'll set the battery aside for now. Right now, I don't have the original relay for this. I tried a lot to find the same one in the market, but couldn't get it, so I'll install a different relay instead. This new relay is 5 amperes, 250 volts, and operates at around 12 volts. However, it's quite different from the old one. As you can see, there's a big difference in both the body and size. So, we'll have to install this new relay instead. So, we'll install the new relay here, but as you can see, there isn't enough space to fit it properly. When we try to place it, it doesn't fit in the existing spot, so we'll use a special technique to install it. we'll insert the wire into the pin so that the solder joint becomes stronger. Now it's done properly, and we'll connect these red wires in the same order. The relay has been installed here, and all the points are properly connected. Now it's ready to use. Now I'll secure this relay so that no issues occur later. For that, we'll use hot glue. I'll apply a little around the sides to make sure it sits firmly in place. We'll need to press it down a bit so that no issues arise and it stays firmly in place. We'll also apply a little hot glue on the wires so they don't vibrate. Similarly, we'll apply some on the other side as well. I'll also apply some glue on top so it becomes more secure and firmly fixed in place. Now our PCB is completely ready. I've finished all the remaining fittings. And look, the fan has started spinning perfectly, running in smooth full motion. The compressor has also started, and it's running properly. However, the fan is vibrating quite a bit, so there's a risk it might get damaged or break. So we won't take any risk. I'll turn off the fan. The fan has been turned off. And our PCB is now working perfectly fine. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.